Hello, this video accompanies Notes 7.1 and Homework 7.1. The topic for this lesson is the Pythagorean Theorem, or the Theorem of Pythagoras. Pythagoras was an ancient Greek philosopher and mathematician. Although this theorem bears his name, he was probably not the first person to figure it out or to notice the relationship. Here's how it works. Suppose we have a right triangle, as shown on your notes. The right triangle has one side that is the longest. On here, it's labeled as side C. It is called the hypotenuse. So the longest side of a right triangle is the hypotenuse, and it's always across from or opposite of the 90-degree angle. The other two sides, labeled A and B here, are called the legs of the triangle. Those are the two shorter sides. The Pythagorean theorem states that for all right triangles, where C is the hypotenuse and A and B are the respective lengths of the legs, then I can take the length of leg A, square it, plus the length of leg B squared, and it will equal the length of the hypotenuse, C squared. Or more simply, A squared plus B squared equals C squared, where C is the hypotenuse and A and B are the legs. Now we'll look at examples in a minute to see how this works. But first, let's consider why this theorem is true or how it works. There are lots of proofs, like hundreds of them, that mathematicians over the years have come up with. In fact, James Garfield, who was a president of the United States, was one of the people who came up with a proof of the Pythagorean theorem. He also happens to be our only president who is also a mathematician. On a more somber note, he was also one of only 4 American presidents to be assassinated while in office. So here is a simple proof, a graphical proof of the Pythagorean theorem. So notice that in the middle of this diagram, I have a triangle. The length of the legs are both 5 units. You can count the blocks. There are 5 here. There are 5 here. We don't know the length of the hypotenuse because it's diagonal. We cannot just count blocks. So what we do is we take each side of the triangle and we make a square out of it. So you can see a square here that's 5 blocks on each side. The same thing here, this blue one. We have 5 by 5 on this square. Then we also draw a square along the hypotenuse. And we don't know how long the sides are of this square because the lines are diagonal. Then what we can do, and you can imagine this, if we draw these red lines here, these diagonals, so we're going to draw diagonals. If we were to cut along these red lines on both the orange and the blue squares, so we cut out all along the red lines, we would end up with 8 little rectangles. Triangles. So we'd have a triangle here, a triangle here, a triangle here, and a triangle here. And likewise on the orange one, we'd have 4 orange triangles. That's a total of 8 triangles. Now what we can do is we can take all 8 of these orange and blue triangles once they're cut out, and we can lay them inside this larger square so that they fit like puzzle pieces, and they form this large square. So when we do that, it would look like this. So if you notice, I tried to indicate where the orange and the blue triangles are here. So we have 4 blue triangles and we have 4 orange triangles, all of which are the same exact triangles that came from these original 2 orange and blue squares. Now there's another way we could do it. Notice that the design is just a little different on this one. So on this one, even though the pattern is different, all 8 triangles still fit perfectly inside the larger square. So what does this tell us? Well, it tells us that the area of the orange triangle added to the area of the blue triangle is exactly the same as the area of the large triangle, because the triangles fit perfectly in this square. So that tells us that this side squared plus this side squared equals this side squared. So it's just a graphical representation of a squared plus b squared equals c squared. So now let's look at the examples. On your notes page, there's an example showing a house with a ladder leaned up against the house. The ladder represents the hypotenuse because it's the longest side of a right triangle. That means if we were to plug in the numbers for A and B, we would get 5 squared plus 12 squared equals c squared. Now remember, your c value is always the longest side, the hypotenuse. By the way, it does not matter if you call 5 A or B, because remember that addition is commutative. It doesn't matter if we say 5 squared plus 12 squared or 12 squared plus 5 squared. They're both the same. Now that we square our terms, we get 25 plus 144 equals c squared. 25 plus 144 is 169. We take the square root of both sides of this equation to get our solution, which is c equals 13. Now, does that answer make sense? Could the length of the ladder be 13 feet? Well, sure, because the height of the building there is 12 feet. So that's a reasonable answer. On to the back side of the paper. We're trying to find the length of the hypotenuse of this triangle. So we set up our Pythagorean relationship, a squared plus b squared equals c squared. If we plug in the numbers 8 and 10 for a and b, we get 8 squared plus 10 squared equals c squared, remembering that c is always the hypotenuse. 8 squared is 64, 10 squared is 100. Add those together to get 164 equals c squared. If I square root both sides of this equation, we get our solution, which is c is about equal to 12.8. We cannot square root 164 and get a whole number. So use a calculator. And as it says in the instructions, round your answer to the nearest tenth. But when you round your answer, the answer is not exact, which is why we use the squiggly equals sign. Does the answer make sense? Could the length of the hypotenuse be 12.8? Well, yes, because if this side is 10 and the hypotenuse appears to be a little bit longer, it is reasonable that it's 12.8. What would be unreasonable is if you got an answer of, say, 86. that wouldn't make sense because it's much too long. Our next example shows a problem that's a little bit different. Notice on this one that the missing side is not the hypotenuse. So when we write our Pythagorean theorem, a squared plus b squared equals c squared, we remember that c is always the longest side. The longest side, in this case, the hypotenuse, is 10. So the 10 substitutes for c. Our missing side is one of the legs. It could be either a or b. I used 6 for a. So we get 6 squared plus b squared equals 10 squared. When we square the terms, we get 36 plus b squared equals 100. Next, we subtract 36 from each side of the equation to get b squared equals 64. Finally, square root both sides of the equation to get our solution, b equals 8. Ask yourself, does 8 make sense? If the length of this side is 6 and the length of the hypotenuse is 10, could this leg be 8 units long? Sure it could. Now let's look at the homework. The homework assignment on number 4 shows a triangle with a hypotenuse that is missing. That's our c value, so we'll write the Pythagorean relationship as 3 squared plus 11 squared equals c squared. To solve this, we will square our quantities, so we get 9 plus 121 equals c squared. 121 plus 9 is 130. And then I square root both sides and use a calculator because 130 is not a perfect square. So we end up with c is about equal, so we use a squiggly equal sign. And if you type this into a calculator, you get 11.4. Number 6. Note that number 6 has a leg that we don't know. The hypotenuse we do know, it is 12. Therefore, the hypotenuse, which is our c value, is 12 squared. Let's square our terms and we get 64 plus b squared equals 144. Next, we want to keep our b squared where it is. So we'll subtract 64 from both sides of the equation. That gives me b squared equals 80. Now again on this one, we cannot square root 80 and get a whole number answer. So we'll use a calculator, take the square root of both sides, remembering that the square root of a number squared, they are inverse operations, so they undo each other, and we're left with b equals, b is about equal to 8.9 if you use a calculator for the square root of 80. So if you have any questions, don't forget to contact me on Remind or send me a question through Google Classroom, though Remind is better because I get those messages any time of day. I hope you guys have a good weekend. Take care of yourselves. Be safe. Don't forget the social distancing. Thank you. See you next time.